All right, this question facing us right here is very, 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 very simple to solve. But most times when students look at it, they'll be afraid and they wouldn't know what to do. They'll be scared and they'll leave without solving it. But the solution is very simple. It is from the simple knowledge of mathematics that we'll be able to solve this question facing us now. Now, if you look at the diagram, first of all, they said that we have to find the value of t from the diagram. And if you look at the diagram, it's already very clear. We have a weight acting downwards, that is 20 Newton. Then we have a tension, the tension in this string or tension in this rope acting in this direction. It is inclined at angle of 30 degrees to the horizontal. Then we have this other one, tension, acting in that same angle of inclination to the horizontal. So it is very simple. All we need to do is to find the vertical component of this tension. Let's find the vertical component and then find the vertical component of this other tension, okay, and then equate it to this downward force, which is the weight. All right, remember that action and reaction are equal and opposite. All right, this is a hanging weight, okay, it's a hanging weight. It's a situation whereby two ropes are used to hang a weight of 20 Newton and it is suspended. All right, so all we need to do is, first of all, how can we now find the vertical component of this weight? Since the angle is inclined to the horizontal, then the vertical component is t sine theta. So from here, the first one is, let's resolve this diagram. The vertical component here is t sine 30. That is this t here, t. Then this other part here, if you resolve it again, you are going to have t, that is t sine 30 again. Then we now have our weight w, which is 20 Newton. You may be wondering, why is it t sine theta? It is with the help of trigonometrical ratio. If we divide this diagram into two, you find out that this is the angle, all right? This is angle 90, all right? This particular part is the what? The hypotenuse of this triangle. So all we need to do is, since this place is the opposite, this line here is the opposite of that angle 30. That's why we said sine 30 is equal to opposite. Let's call it x. We call it x. Sine 30 is equal to opposite over hypotenuse. That is sine 30 equals x over t. Remember that what we want to find is the vertical component, which is x. So we are going to make it the subject of formula. That is x is equal to t sine 30. All right, for this part. That means the vertical component here is t sine 30. That is what we have written here for this left hand side. Then you do the same thing here, and that is why we have t sine 30. I hope it is very clear. So this diagram, from this diagram, we now have that the total upward forces, that is t sine 30 plus t sine 30, is equal to the total downward force, which is what? 20. Then from that relationship, we now have that t sine 30 plus t sine 30 is equal to 20. How did I get this? T sine 30 plus t sine 30 here, all right, is equal to 20. That is the total upward force is equal to total downward force. It's very simple. So when you have t sine 30 plus t sine 30, we now have 2t sine 30, and that gives us what? 20. All right, let's write it well, 20. Then for us to be able to, of course, sine 30 is 0.5. Okay, so we have 2t multiplied by 0.5 is equal to 20. All right, okay, then 2 times 0.5 is what? 1. Yes, 0.5 is half. So 2 times half is what? 1. So 1 times t is what? T. T is equal to 20. All right, so we've gotten the value of t to be equal to 20. Remember that the units have to be consistent. So this is 20 Newton. Then the tension in the strings have to be the same. So we have Newton, right? This is very simple. Don't run away when you see this type of question. I promise you, it is very simple. Thank you very much, and God bless you. Bye-bye.